All right, next bit, multiplicative identities and inverses. Okay, so what does it mean to be a multiplicative identity? All right, so what you're thinking about is what can we multiply by anything and it does not affect the value of the number. Okay, and so hopefully you're thinking to yourself that the multiplicative identity is 1, and that is true because if I multiply 1 by anything, all right, if I multiply 1 by anything, though, I'm going to end up with whatever I started with, right? Because 5 times 1, oh, let's go back here. 5 times 1 is equal to 5. 17 times 1 is equal to 17, right? That 1 doesn't affect it when I multiply it by any value. That means it's a multiplicative identity. It stays the same, okay? And an inverse, this is a little bit harder to think about, but it's really what is the value that when I multiply it by a number, I have an output that is the identity. Okay, so let's think about this for a second. 2x is equal to 1. Well, what would that mean x would have to be? X would have to be 1/2 then, right? How about 5? 5 times what number is equal to 1? Well, that would have to be 1/5. All right. And let's just do one more. 4/3 times what number is going to equal 1? And you remember how you're going to do this? You're going to multiply by the reciprocal, right? And you're going to end up with x is equal to 3/4. So we can look at this and say, well, 2 times 1/2 is going to give me that 1. 5 times 1/5 is going to give me that 1. 4/3 times 3/4 is going to equal the 1. So when we have reciprocals, they are multiplicative inverses. Okay, because they will yield 1 when they are multiplied together. Okay, so this is all the numeric background to kind of remind you of what these things are. And so now let's talk about it in terms of matrices, okay? An identity matrix is a matrix that is square. Okay, it's got to be square. And square just means it has the same number of rows as columns. It's a 2 by 2 matrix. It's a 4 by 4 matrix. Same number of rows and columns. Okay. And this square matrix will have ones, the value of 1 on the main diagonal. And that's from the top left to bottom right, and zeros in every other position. Okay, so an example of this, if I'm thinking about an identity matrix, 1 1 0 0. That's an identity matrix. It's a 2 by 2 identity matrix. A 3 by 3 identity matrix would be 1 1 1 on the diagonal, and every other position is filled with a 0. Now, remember what a multiplicative identity did, right? A multiplicative identity, it was something where a number multiplied by 1 gives you the same number. And these identity matrices are going to do the same thing. When multiplied by another matrix, and you've got to have the appropriate dimensions, the result will always be the original matrix. Okay, so when we're talking about anything times an identity matrix will yield the matrix you started with. Okay. Oh, like here. So if I had something like this, 5, 4, 3, 2, multiplied by 1, 1, 0, 0, I'm going to end up with 5, 4, 3, 2, because this is the identity matrix. This is some matrix, we can call it matrix A. Anything times the identity matrix will yield what you started with. All right, next thing we're going to talk about is how do you find the inverses of matrices, okay? If we're talking about a 2 by 2 matrix, this is an easy one for us to come up with by hand. We don't need to use our technology to find the inverse of a 2 by 2 matrix. You can find inverses of 3 by 3s, not too terribly hard either, but a 2 by 2 is really very quick and easy. Let's say that I've got matrix M to be defined as A, B, C, D. Okay. Then if I'm interested in the inverse of matrix M, and I would just notate that like I have with other kinds of inverses. Remember F inverse with that superscript of -1. What I'm going to start with is this fraction 1 over, and I'm going to multiply A times D. All right, we're going to multiply AD, and I'm going to subtract BC. All right. Okay, so I'm going to take A times D, subtract B times C, and then I'm going to multiply that by every entry in this matrix. I'm going to take and I'm going to switch the positions of A and D. So upper left will be D, bottom right will be A. And I'm going to switch the signs of the B and C's. So I'm going to make this negative and make this negative. So switch the position and make these negative is really kind of what we're doing. All right, so let's try one, okay? Let's try one. Let's say that we've got this inverse, or this matrix A, -1, -2, +3, +4. And we're going to find this 1 over, okay? And so A times D, this is going to be -1 times -4. We're going to take this right here. So -1 times 4, -4, minus B times C, 3 times -2 is going to be -6, so minus a -6. Okay, so when I have 1 over -4 minus a -6, this is going to be a +6, and so we'll have a positive 1/2. All right, let's go ahead and let's get rid of that too. All right. So now let's put our entries into this matrix, and remember we're going to take the left to right diagonal. We're going to switch those positions. So the -1 goes in the bottom right, the 4 goes in the upper left. And then we're going to change the signs, make these negative, okay? And so this is going to be +2 and -3, okay? And then all I'm going to do is take this 1/2 and distribute it to every entry in this matrix. And then I'll have my inverse. So 1/2 of 4 is 2, 1/2 of 2 is 1, 1/2 of -3 is -3/2, and 1/2 of -1 is -1/2. And that would be our inverse of this original 2 by 2 matrix. You could check this on your calculator, and the way you would do that is the way that you would find your inverse from anything that's higher order. There are some matrices that are not invertible. They don't have inverses, but most of them do. So the only thing that you would really need to be able to do by hand is a 2 by 2. Anything beyond that, you would just want to enter a 3 by 3 matrix into one of your matrix options in your calculator, and then use your calculator with, here's your calculator, with that inverse and raise it to the -1, just find the inverse, and then you would be able to get an output, and you should be able to get that 3 to -4, 3, -2, -5, and -1, +1, +2. Okay, so you could definitely check this 2 by 2 by using a calculator, but you should be able to find it by hand, and that would be following these steps. Okay, now how do you know if two matrices are inverses? Well, remember, if two numbers are inverses, right, 5 and 1/5 are inverses, I get an output of 1. If two matrices are inverses, when I multiply them together, matrix A times matrix B will equal the identity matrix that is the appropriate size. So I'll end up with a square matrix with ones on that main diagonal. So I want to know if these two matrices are inverses of each other. And the way I'm going to do that is I'm just going to enter matrix A into my calculator. It's a 2 by 2 matrix. And I'm going to try to enter matrix B into my calculator. And then if I multiply matrix A times matrix B, I should end up with an identity matrix, 1, 0, 0, 1. Okay, so if it's true, then matrix A times matrix B will equal 1, 0, 0, 1. Okay. Or you could do it by hand. You know, a 2 by 2 matrix you could easily do by hand and see if that's true. Okay, and I'm gonna leave that up to you.